Hello everyone. This is an example video for extracting features from graphs. So let's say you're given a wave function. It could be either a sine or cosine wave function. And you're given these 2 points on the graph. This lower one here is a trough point, and this one at the hilltop here is a crest point. So let's say you're given these two, and what we want to do is answer a few different questions about these. So the first question we want to answer is the distance between A and B. So in other words, let's label these. This is going to be A and this is going to be B. If my pen would work. There we go. All right, so the first question we want to answer is the distance between A and B, the x values of these 2 points, is equal to some proportion of the period of this function. And we want to figure out what proportion the distance between these 2 points makes of the period. So we're not actually trying to figure out what the period is for this first question. We'll do that later. We're just trying to relate the distance between these 2 points horizontally to the actual period of the function. You can do this actually without knowing what the coordinates of these points are, like the 3 pi and the 4 pi. You could do this by just knowing that one is a crest point and one is the adjacent trough point. All right. So how would we go about tackling this problem? Well, it's sometimes a good idea just to get a visual of what the full period is and then relate that to the distance between the 2 points. So what I'm going to do first is extend this graph a little bit. Something like this, best of my artistic abilities. All right, and I'm going to mark the next trough point. Actually, this is not a good drawing. So let's see if I can spruce this up a little. It should come just down just as much as the other crest point or trough point. No, that's something like this. All right, and I'm going to label the other trough point. All right, so a period of a wave function is determined to be the distance from one trough point to the next trough point. Alternatively, if we didn't have 2 troughs in this drawing, if we'd had 2 crests, we could also measure the distance between any 2 adjacent crest points. But it's always going to be the distance from one point on the graph to the next adjacent part of the graph. So crest to crest, trough to trough. If you're doing some other point in module 5, for example, you might have inflection point to inflection point on a tangent graph, or asymptote to asymptote on a secant graph, something of that nature. But you always go from adjacent point to adjacent point. All right, so like point to like point. This distance between this trough point and this other trough point is equal to the full period. All right. We need to relate that somehow to the distance between the crest point and the trough point that we were given. All right. So looking at this diagram, you'd guess, and you'd guess correctly, that the distance between the 2 points, the 3 pi negative 5 pi over 3 and the 4 pi and negative 1 over 3, the distance between those 2 points horizontally is exactly half the period. And that is correct. So the nice thing about these trig function graphs is that they're very kind of repetitive. They're very symmetrical as well. So anytime you have key points on a trig graph, it always splits into like four kind of nice components by its key points. So if this is one full length of the period, for example, you might view it as like this trough is a key point, the midpoint over here is a key point, the crest is a key point, the next midpoint is a key point, and this trough is a key point. These key points always divide the period into four equal pieces, and that's going to be true of all our trig functions, even the ones we study in Module 5. So the distance between key points is always going to be a quarter of the period. So in total, there's 2/4 of the period between the 2 points A and B. So 2/4, that simplifies to 1/2. So our answer is going to be 1/2 of the period, which you could just write as P over 2. Now in Kronos, this is what they're asking for. They're asking for some fraction of capital P. Once you answer that question and the corresponding amplitude question, it's going to pop up an actual place for you to actually type in the period and the amplitude. So always read your questions carefully and figure out what they're asking. Don't just assume they're wanting you to type in the period or the amplitude. In this case, they're wanting a ratio of the period, not the actual period. Okay, so we've done that now. You probably can guess what we're going to do for the next question. The next question is going to ask for the vertical distance between f of a and f of b, and it's going to ask for it in terms of the amplitude, so some ratio of the amplitude. Let me erase a few things here. So we're done looking at horizontal distance now. Now we're looking at vertical distance. Amplitude is a vertical measurement. Right? So the amplitude here typically is defined as the midpoint of the graph up to the next key point. So the midpoint is right here, and you go up to the next key point or down to the next key point. Doesn't matter which direction you go because these graphs are symmetrical. All right, and we want to measure this vertical distance here. That's going to equal the amplitude when we get to it. All right, but again, this first question, I'm not actually trying to find the amplitude. What I'm trying to find is this distance between f of a and f of b. It's equal to what proportion of the amplitude? All right, so I've drawn out what the amplitude would look like as a vertical bar. Now let's draw out what the distance between f of a and f of b is as a vertical bar. So that's going to be this whole vertical distance here from f of a to f of b. All right, and roughly eyeballing this, you'd say the distance between f of a and f of b is twice the amplitude. And you would be correct because, again, these trig functions are very symmetrical. If you go from midpoint to up to key point, that's an amplitude. If you go from midpoint down to key point, that's an amplitude. So if you go all the way from upper key point to lower key point, that's twice the amplitude. So the answer for Kronos for that question would be 2 times capital A. All right, so there's the two confusing questions. Now let's actually do the more straightforward questions, which is to calculate the amplitude, period, frequency, and vertical shift. All right. And you can actually use the two problems we just answered to calculate the period and amplitude. So I'm going to write the results we had for those two questions up at the top here, even though I erased some work we did. So we know b minus a equals half the period, and we know f of b minus f of a equals 2 times the amplitude. Let's look first at the period and calculate what the period should be. All right, so we know what a and b are. They're the x values of these 2 points that we were given. So b is 4 pi and a is 3 pi. So we subtract them and that should equal half the period. Pi is not a variable, pi is a number. So this is an equation with only one variable p, so we can solve for p. Simplify the left-hand side, get pi is equal to p over 2. Multiply both sides by 2, and get that the period equals 2 pi. All right. So this is not always the case with these transformed trig functions that have been altered. It's true for the standard ones, like the graphs of sine of x and cosine of x that aren't messed with. They always have a period of 2 pi. But once we start stretching them, it can change the period. All right, so now let's do the same thing for amplitude. So we know f of b minus f of a is 2 times the amplitude. We know what f of a and f of b are, and be careful because we're working with negatives here, so always be careful subtracting negatives. It's easy to forget a minus or a negative sign somewhere. So f of b is negative 1/3. F of a is going to be negative 5/3. And that should equal twice the amplitude by the answer that we got for the last question. All right, so now we're going to subtract these. Whenever you subtract a negative, it's the same as plus a positive. So this is negative 1/3 plus 5/3, which is equal to 4/3. And that should equal twice the amplitude. So we're going to divide both sides of this equation by 2 and get that the amplitude is equal to 2/3. All right. Sometimes depending on how you do subtraction, you may end up with a negative amplitude. That is always incorrect. Amplitude is defined to be a distance, and so is period. So if you end up with a negative answer, you've either done something wrong or you've just subtracted in the wrong order, in which case you should just make your answer positive. All right, now the next 2 questions you're asked is to find the frequency and the vertical shift. The frequency is easy. It's defined to be the reciprocal of the period. So the frequency here, frequency will equal 1 over the period, which in this case is 1 over 2 pi. Now in Kronos, you'll have to enter this as 1 divided by parentheses 2 pi. Otherwise, it's not going to understand what that pi should be in the denominator. Now the vertical shift isn't quite as easy, but it's not that difficult. So let's scroll back up to our graph. All right. The vertical shift of any trig function is always going to be the y value of any midpoint on the graph. So sometimes the midpoint is given to you as one of your points. In this case, we're not given a midpoint, so we got to figure that out. So we are looking for this point here. Specifically, we're looking for the y value at that point. All right, but remember, these graphs are all symmetrical, so that point vertically should be exactly half the way between this f of b and f of a. So in other words, we want to find the average of those 2 y values. So how do you find the average of 2 values? Well, you add them together. And my pen still is giving me issues. I hope I don't need to buy a new one. There we go. All right, so we add them together and divide by 2. That's how you always find the average of any 2 numbers. So if you add negative 5/3 and negative 1/3, you get negative 6/3, which is negative 2. Negative 2 over 2 is just negative 1. So your vertical shift for this problem would be negative 1.